Chapter 2, Section 4, Practical Applications of Vectors. In this section, you will learn the concept of feature vectors, a kind of vector, and the concept of distance measures. Also, how feature vector and distance measures are applied in data science. A feature vector is a vector that represents the features of a data point. Each component of the vector corresponds to a specific feature, and each value in the vector represents the observed value of each feature. A feature vector is an n-dimensional vector that encapsulates all the features of a particular observation in a dataset. Mathematically, a feature vector x for an observation in n-dimensional space can be represented in this way. Here, x1, x2, xn are the values of the features for that observation. Consider a dataset containing information about customers with three features: age, income, and a purchase amount. A feature vector for a specific person looks like this. In this example, the first element represents this person's age. The second element represents the income. The third element represents purchase amount. By representing each person as a feature vector, we can mathematically analyze the data more efficiently. Feature vectors have numerous applications in machine learning. Let me show you several examples. The first is regression. In supervised learning, we can use feature vectors to train models to classify or predict outcomes. For example, a model might use feature vectors representing customer data to predict whether a customer purchases a new product. The second is clustering. In unsupervised learning, feature vectors can be grouped into clusters based on similarity. For instance, customer data represented as feature vectors can be clustered to identify different customer segments. We can use vectors to quantify the similarity between data points. Similarity is an essential concept in machine learning applications, such as clustering and anomaly detection. In machine learning, we can represent the similarity between two data points using distance between two vectors that are feature vectors of each data point. The Euclidean distance is the most commonly used distance measure. It represents the straight line distance between 2 points in Euclidean space. For two vectors, u and v in n-dimensional space, the Euclidean distance can be computed in this way. Consider two feature vectors representing two persons. Here, the features are body height and weight. The Euclidean distance between these persons can be computed in this way. Distance measures are applied to machine learning in various ways. The first example is k-nearest neighbors. This algorithm uses distance measures to classify data points based on their proximity to other data points. A new data point is classified by majority vote based on the distance between feature vectors. The second example is clustering. Clustering algorithms like k-means use distance measures to group similar data points together. Data points that are closer to each other are more likely to be in the same cluster. The third example is anomaly detection. We can use a distance measure to detect anomalies by identifying data points far from most of the data. Points with large distances from other points will likely be considered anomalies. Feature vectors and distance measures are essential concepts in machine learning, providing a mathematical framework for representing and analyzing data. Feature vectors enable us to describe data points in terms of their characteristics and can be used for regression and clustering. Distance measures enable us to quantify similarity between data points, which can be a foundation for k-nearest neighbors, clustering, and anomaly detection. Thank you for watching. Please thumbs up and subscribe to my channel.